Hey, how's it going there? So we've been working with derivatives so far in the chapter that we're currently studying. And one of the things that we said early on in the chapter is that a derivative tells you the slope of a tangent line. The derivative of a function always tells you the slope of a tangent line, and you can do that at specific points on the function. What we're going to do is we're going to take that idea a little bit further in this video, and we're going to try instead of figuring out the slope of a tangent line, we're going to try to figure out the equation of a tangent line. More specifically, the goal here is that you're going to be able to find the equation of a line that is tangent to a function at a given point. So where I could pick any point on the graph of a function, and I could find out what is the equation of the tangent line that goes through it. Now, how is that process of writing the equation of a tangent line at a given point on a function going to work? Well, let me give you the graph of a function here, and let's just suppose that function is y is equal to f of x. So y is equal to f of x. Now, remember this you already know, that if I were to try to pick out any point on this graph, and I was to try to find the slope of the tangent line at that point on the graph, then I would have to use a derivative to do that. So let's suppose on this graph then that I choose this as a point, and what I'm going to do is I'm going to label its coordinates as a, comma, f of a. And the goal then is going to be for us to be able to write the equation of this line that's tangent to the graph of y equals f of x at that point a, comma, f of a. Well, I've already reminded you of this. The slope of that line is simply going to be given by the derivative of this function. Now I'm going to be a little more specific than that. The slope of the tangent line at that place where the x-coordinate is equal to a is going to be given by f prime of a, meaning you take the derivative of the function, and then whatever the derivative equals, you're going to substitute a into that derivative, and that will give you the slope of the function. All right, you've worked with that before. Now, if I'm trying to find the equation of a tangent line, why am I talking about the slope? Well, whenever you're trying to find the equation of a line, one of the things that you need to know is the slope. And another thing that you need to know is a point that's on the line. Now, recall that you know how to write equations of lines in this form right here. Point-slope form, in other words. And that's what we're going to do to write the equation of the tangent line, is simply we're going to go ahead and figure out what its gradient is. And we'll do that, of course, using the derivative that I just said right there. That'll be f prime of a. And then what we're going to do is we're going to plug in the coordinates of one point on the line. And the only point that we're going to know is on the tangent line is the point of tangency for that line with the curve y equals f of x. And so what we're going to do then is we'll plug in the x-coordinate a right here for x1 and the y-coordinate f of a right here for y1. And that would look like this. We could say that the equation of this line is simply y minus f of a. Now that's just y minus y1. And that's equal to f prime of a, which remember is the slope of the line, times x minus a, which is simply x minus x1. So we're going to combine finding the slope of the tangent line with using the point-slope form of the equation of a line in order to write the equation of a tangent line at a given point. Now let's see an example or two of that. The directions for this problem are telling us to write the equation of the tangent line to the curve f of x equals 4 over x squared at the point 2, comma 1. Now this happens to be the graph of y equals 4 over x squared. Wanted to include that there. And I want to also show you this, that indeed the graph would go through the point 2, comma 1. That was a little bit off. Let's try to put that right here instead maybe. Good. And what we're trying to do then is we're trying to find this tangent line. Now, beyond just making it look like this graph goes through that point, consider this. If I were to plug in 2 for x in this function right here, then I would have 4 over 2 squared, or 4 over 4, which is 1. So that's another reason why I know this graph goes through the point 2, 1. Okay, so let's find the equation of that tangent line right there. Well, I said what we're going to do is use this form. Okay? And a little bit of that we can go ahead and fill in already because we already know what the a and the f of a are. That's just the x and y coordinate for the point of tangency. So we would know that this equation is going to be y minus 1 is equal to f prime of a. Now, a is equal to 2, isn't it? Because a is the x coordinate for that point. So it's going to be equal to f prime of 2 times x minus 2. But we still have to figure out what f prime of 2 is. So I'm going to come down here and work that out. It's going to require us to take a derivative. All right, now, of course, that function f of x equals 4 over x squared, we would rather write that as 4x to the negative second power in order to do the differentiation with the function. And then we can go ahead and use our power rule combined with the constant multiple rule in order to figure out what that derivative is. We're going to go ahead and multiply negative 2 times 4 and get negative 8x to the negative third power. And then that'll be negative 8 over x to the positive third power. Now what f prime of 2 means is that we're going to plug in 2 into that function f prime of x. All right, so let's do that then. F prime of 2 would be negative 8 over 2 cubed, which of course is negative 8 over positive 8, or negative 1. And down here, this is simply the derivative, let's say the slope of the tangent line at that point of tangency. And so all we got to do is plug that now into our point slope form right here. And voila, we've got the slope of the tangent line. Now, you can just simply leave that, the equation of the tangent line. That's what we have, voila. And you can simply leave that equation written in point slope form, such as it is right there. You don't have to change it into y equals mx plus c form. Great. So find the slope of the tangent and then plug it into point slope form. That gives you the equation of a tangent line at a given point. Want to do one more example, but I think you've got the idea right now. And really, I want to show you this example just so I can show you one little extra thing that can be thrown in to a problem such as this. Now, you see the function that we're going to try to write the equation of the tangent line for is f of x equals 6 squared of x minus 3x. And this is the graph of that function. Just got it from a graphing utility. But this time it doesn't tell us what the exact point of tangency is. All it says is that we're finding the equation of the tangent line at x equals 1. And so the added step with this one is we're going to have to find out what are the coordinates of the point of tangency. Now, if we're looking at when x is equal to 1, we're looking at this point on the graph right there. And so its coordinates are going to be 1 comma something. And in order to figure out what the y coordinate for the tangent is, what we're going to have to do is plug in 1 into the original function. So let me do that. F of 1 will be equal to 6 times the square root of 1 minus 3 times 1. And that's just going to give us 6 minus 3, or 3. And so that's the y coordinate for our point of tangency. And now that we know the y coordinate for the point of tangency, we can go ahead and go through the same process we did a moment ago. We know much of the equation of the line already. We can say that it's going to be y minus 3 equals f prime of 1, because that would represent the slope of the tangent line when x equals 1, correct? Times x minus 1. So there's my x1 and my y1 from the point of tangency. So the last thing we've got to do here is figure out what f prime of 1 is so that we can figure out the slope of the tangent line and include that with our equation. Now, in order to find out what the derivative is, you're going to notice I rewrote the function so that it didn't have a radical. I wrote it in as a power term instead, 6x to the 1/2. And then let's go ahead and figure out what f prime of x is. That'll give us 3x to the negative 1/2 power minus just 3, right? Because 1 times 3 is 3. Then you get x to the 0 power, which is just 1. And then we can write that ultimately as 3 over the square root of x minus 3. Because that negative exponent would tell us to bring the x down to the denominator. And then since it would be x to the positive 1/2 power, we can write that as the square root of x. Hopefully that makes sense. And then the last thing we need to do with this is we need to plug in the x value from the point of tangency so that we can see what is the slope of the tangent line at that point. So we're going to figure out what f prime of 1 is, which is what we've been saying all along we were going to do. And f prime of 1 is, of course, going to be 3 over the square root of 1 minus 3. Now that's really just 3 minus 3, or 0. And so the equation of the tangent line could be written as y minus 3 is equal to 0 times x minus 1. Now, while I've got your attention on this, you're probably saying I don't need to write this as 0, 0 times x minus 1, and you're right. But here's the thing that I wanted to point out while I have your attention, is that there's a special property about a point if the slope of the tangent line at that point is 0. And simply that property is that this point either has to be a maximum value on a curve or it has to be a minimum value on a curve that kind of opens downward. That's a concept we'll get into a little bit later on. Now, I would accept the equation of the tangent line written this way, and if you went ahead and multiplied out that 0 on the right side, you could write y minus 3 equals 0. And if you wanted to go a step further, you could just say the equation of the tangent line here is just y equals 3. Kind of your choice. All right, now you know how to write the equation of a tangent line for a curve at a given value of x. Thank you for your attention.